Welcome everyone to the June webinar. Today we're going to talk about RETscreen. We have two presenters, Javier and Maria, and I have never met either of them. I've never even spoken to Maria. So I am not the person to introduce them and tell you why you should listen to them. They are going to do it themselves. I have this feeling that they know a lot about RETscreen because they present about it all the time. So I guess I have nothing else to say. So go ahead, Javier and Maria, please introduce yourself and then go ahead and start the webinar.
Maria, please start.
Hello everyone, my name is Maria Blesa and I'm the new energy engineer in training at Hysovent. I hold certifications as a certified energy manager, RETscreen expert, and measurement and verification professional. I bring over 4 years of experience in energy audit verification, energy modeling, and GHG emissions quantification. I worked extensively with incentive programs, particularly in reviewing and validating energy models and savings calculations for compliance and funding approval. I've also delivered technical training both in English and Spanish, and my academic background includes a bachelor's degree in energy engineering from the University of Calgary, along with a mechanical engineering technology diploma from SAIT, which really supports the practical and technical side of my work. I'm especially passionate about using data to uncover real energy savings and help organizations reduce their carbon footprint. And that's a little bit about me.
Excellent. Thank you, Maria. So for myself, I'm Javier Ojeda. I'm the owner and founder of Principal Engineer of Hysovent. We are a company focused on engineering and project management consulting for renewable energy and energy efficiency, located here in Halifax, Nova Scotia, Canada. I hold those certifications that you see there: project management, certified energy management, and renewable energy professional from the Association of Energy Engineers, and as well as the certified RETscreen experts. I have a little bit of over 20 years of experience in renewable energy efficiency, experience managing large hydro plants and small hydro plants as well, and a lot of interdisciplinary expertise on energy audits, hydro overhauls, plant management, and feasibility studies. Today we will be talking about what's RETscreen, right? How it can be used for energy audits and how it can be used for measurement verification. I will be talking about the use of RETscreen for energy audits. Maria will be talking about RETscreen for measurement and verification applications, right? So what is RETscreen? RETscreen Expert is a clean energy management software developed by Natural Resources Canada and available worldwide that supports feasibility analysis for energy efficiency, renewable energy, and cogeneration. It includes ongoing performance analysis capabilities and helps to decision makers to make decisions related to project development, strategy planning, and best prioritization. What is not RETscreen, which will be curious, is in fact that RETscreen is not an engineering design tool. You cannot design on RETscreen, but you can test your design on RETscreen. That's an interesting point of view. On RETscreen, you don't size the equipment. You put the inputs of the equipment that you already selected or that you already have in mind. And of course, it's not a substitute of your engineering team or your energy consultant. It's a very, very powerful complement to your engineering process, though. So again, we are going relatively quick here. So how can we use RETscreen for energy audits and emissions estimation? So basically, it follows a 10 steps approach, where you select first your location, determine the facility, model the location itself, the entire facility, study the costs, study the emissions, and develop a finance model and a risk model. And after that, if you want, you can run a data analytics analysis. That's something that Mariana will be talking about. So let's go to RETscreen. So as you see, this is the very first screen of RETscreen. This is the very first introduction, right? So right there, you can see all the different models that it has, from the virtual energy analyzer, which is a very powerful tool, to examples of the type of facilities with different energy efficiency and energy consumption and energy generation examples. So, but we are going through a very interesting facility here. So what we are doing is we will be modeling a hotel facility located in Halifax, Nova Scotia. So, of course, again, this is a real life case. This is not an example. I can model any kind of facility anywhere in the world using its climate data location, which is in fact obtained in real time from meteorological stations on the ground and from satellites. So again, the reach is global, right? So you can simulate things in North America, South America, the Caribbean, almost in the middle of the ocean, in Africa, Europe, Asia, Eurasia, whatever, right? Absolutely wherever. And you will get the most up-to-date meteorological data. So you choose your facility. Check that we are going step by step. So you choose your facility. In this case, we are doing just a small house. Yes, small house, but it can be anything. It can be a power plant. It can be a commercial institutional building, and from there you can build even a multi-unit unit. You have a plethora of examples and a plethora of setups to choose from. Or we don't. That's why we prefer to do not talk about buildings only, because it's not just with buildings. You can definitely simulate all kind of facilities over there, right? After you select your facility and your type of facility, you start to populate information about the benchmark of the energy consumption based on the energy consumption that you already have from your energy audit, right? So that's your very first step on your energy audit. You collect the energy consumption information that you got from your customer, correct? You start to populate that, and from your site visits and from your study of that facility, you start to build an energy model of your facility. The very first step is selecting what are the fuels that are being used on the facility as the source of energy. And that's an interesting concept that RETscreen has, fuel. Fuel is everything that can deliver energy to the system, and that at the facility. That includes electricity. So electricity is treated as fuel, correct? You as well update your schedules, which are basically your thermostats, right? On the different areas that you already predetermined or that you will be building on your energy model. We will talk about that in a moment. So this is very important, because remember that the main energy consumption of any building or any facility in the majority of the cases is the HVAC. So having the thermostat already set up on the current setup, which is the one that you are getting from your energy audit, on the future setup, which is the case that you were proposing, and we will talk about the proposed case in a moment, which is the the more efficient way to work. You have to put it here. Then you go and start to populate the equipment, the heating and cooling equipment that is on that building, on that facility. From heat pumps, if there is in-floor heating, you can put in-floor heating. If you have domestic hot water, you put it there. You have electric heat, whatever equipment that is used for heating or cooling, and you route that right here on the ribbon. So you select the kind of equipment, and it will be added to the list of equipment that you are producing, that you are putting there, and you will populate the characteristics of that equipment. Where you get that information? From your energy audit, from your drawings, for your walkdowns. All right, and you can use something very powerful. I use it all the time. Again, for privacy reasons, it's empty in this case. is the notes. The notes on every page, you can even put drawings if you want, pictures, your field notes, everything. So when you are building your model, you're not forgetting from where that information is coming from. Then you start to build your envelope, which are the different areas of your facility or building. And that's the beauty of RETscreen. You can go as detailed as you want to put even try to simulate thermal breaches of the different isolation strategies that building has. The different walls, windows. Again, window by window if you want. In this case, we simulate a window by window. The composition layer by layer of the different walls of the roof. If you have different rooms with different compositions, you can put that in RETscreen and build a very detailed energy model. Or you can go very quick and just basically put percentages on the different fields, right? But for matters of time, we will not go in detail on that, but RETscreen can be as detailed as that. And right there, it gives you what is called the base case and the proposed case. The base case is what you are finding in your energy audit. Your proposed case is related to the energy efficiency proposal that you are delivering to the energy model itself. So, and right there it tells you what will be the impact on the energy saved. If this number is negative, that means that your proposal is in fact using more energy than what is currently right now. You can go and select the different ventilation systems, room by room, space by space, floor by floor, or a global ventilation system. The lights, in fact, in this one is very simple because it was just one floor, but you can go again to be very precise on the different type of lights. You have level 1 and level 2, and then again you have a base case and proposed case. Or if your building still using incandescent or fluorescent lights, you can improve it to LEDs if it's a possibility, or other kind of solution. You can simulate that here, and it will give you the amount of energy that is consumed, and as well, what is the impact on the space heating and cooling, the different electrical appliances, what's the use of domestic hot water on the building or facility, if any, the different fans that the HVAC system has installed, one by one or by group. Right, you can go as well and simulate the different motors that are not fans, for example, motor or even pumps. You do that. You can simulate everything. The compressor is amazing. It's really cool. This model, you can do that, and this is the beauty of the software. So definitely, it helps you to simulate even a production process if you want. That's what I said. Let's not get tied too much to just buildings. As well, you can optimize the energy supply, adding, for example, if you want to add a solar air heater or a solar water heater, or if you say, you know what, I want to put on this facility a photovoltaic system or a wind turbine or any other source of green power, or if I have a PPA agreement or energy procurement agreement for off-site renewables, I can put it there, and even simulate heating, cooling, and electricity storage, right? The best aspect of this is that, as I remember that I mentioned the selection of a base case and proposed case. When we talk about proposed case, it's about energy efficiency measures. So I can put on the model all the energy efficiency measures that I want and that I identify. But at the end, when we are talking with our customers, we can determine what are the energy efficiency measures that I will apply, right? The ones that have budget, the ones that are more aligned with the goals of the asset owner, the ones that are more feasible to do. You select them or unselect them, and from there you can check the impact right away on your different aspects, like, for example, the energy savings that you will get, the fuel consumption, the emissions. You can do that, and it will be changing this in real time, right? For example, if I said I don't want to change anything regarding ventilation, I unclick this, and immediately this starts to change in real time, right? So from that, you as well can calibrate the model using the energy consumption from different fuel types. This is information that you get from your energy audit, and determine how aligned is your energy model with the reality. Normally, a good energy model should be plus minus 10%. Now we are saying plus minus 2%. The best part is that RETscreen disaggregated to a breakdown of the different where the energy goes in your base case and in your proposed case. If you want to do the proposed case here as well, it will show you what's the right here. No, this is only the base case. Sorry. So, but you can do the proposed case. So sorry, I couldn't do it at the demonstration. But yeah, so it can do that kind of analysis, and even you can scale the model to different size of buildings if you have the same building or very similar building but a little bit bigger or a little bit smaller. So you can build that, and of course you can do a full cost analysis, because that's a beauty of RETscreen, that you got here the option of putting the different costs of every energy efficiency measure that you have, and you even have a database of costs of different equipment or different systems that will help you to have an idea of what's the cost of different things. All right. You can, and again, you can be very detailed. You can be or on a really high level cost analysis, medium level cost analysis, on a very detailed level cost analysis with all kinds of factors and variables. Of course, you do emissions analysis. Again, you have 3 levels, and you can simulate specifically the different grids that you are working on. So if you, in this case, it's the grid of Nova Scotia, you select that. I mean, you see that in the level 1, right? But if you are building a very specific grid, or you know exactly what's the fuel consumption of your specific grid, you can select that, and you can build that on RETscreen very detailed. And RETscreen will give you the opportunity to build a financial business case, simulate what will be the financial behavior of your project with different scenarios depending on the fuel cost escalation, the inflation rate, etc., right? And when you choose or select or unselect a measure, right, it affects immediately the finance, it affects immediately the emissions, because everything is being affected in real time, right? So you can show to your decision makers what's the impact of doing or not doing something right away. And you can as well build a risk analysis when you compare variables against each other and see how, if the variables change, improve or not, or not improve, how's the effect on the project, and how it can benefit or affect, impact negatively the project again in real time. It does Monte Carlo analysis with different iterations, and it will give you what's the net present value variability in different cases. And then you can do the data and analytics aspect of your model. So, and that's what Maria Elena will be talking to. So Maria Elena, it's all yours.
So, all right. So Javier explained RETscreen's feasibility analysis module. He showed how powerful the tool is for modeling energy audits and evaluating project potential. Now we are going to move into measurement and verification, where we will focus on the IPMVP option C, whole facility. This approach is often used within RETscreen, and it's especially useful when evaluating energy savings across an entire building. We won't be diving deep into M&B theory today. Our focus is on how RETscreen can be used as a practical tool for real-world M&B applications. If you're interested in learning more about M&B methodologies, I highly recommend checking out the IPMVP framework published by Evo. Also, I'll be sharing a great resource at the end, a guide from Natural Resources Canada on how all IPMVP options A, B, C, and D can be implemented in RETscreen. So why do we need measurement and verification? In energy projects, it's critical to confirm whether a retrofit or operational change actually saved energy and how much. That's where M&B comes in, and RETscreen's performance analysis module gives you the tools to track, monitor, and quantify energy savings, even when the situation includes non-routine adjustments like added equipment, new occupancy patterns, or extraordinary events. On the slide, you can already see a sneak peek of some of the some of RETscreen's built-in capabilities. Things like regression analysis, QSUM chart, and M&B graph, all designed to help quantify savings with transparency. Now, I'll jump into a live demo so I can show you how it works in practice. To begin, I want to highlight that RETscreen has a large library of built-in case studies that have been developed over the years to help users get started quickly with real-world examples. If you navigate here to case studies and filter by performance, you'll find several M&B examples, many of which include the non-routine adjustments that may be relevant to your own projects. This may include a temporary spike in a laboratory, the addition of air conditioning, a facility expansion, a switch in the manufactured product in an industrial facility, even a mini model addressing the COVID-19 impacts. So today we'll walk through one of these examples, but I encourage you to explore the others on your own. I'll provide a link to download the latest version of RETscreen at the end of the session. The example we'll walk through is this one, the 1-month event in a laboratory. In this case, research activity intensified for the duration of 1 month, resulting in a temporary increase in electricity consumption during the reporting period. The goal is to apply a non-routine adjustment so that the savings calculation fairly accounts for that anomaly. Okay, I have it open already, so I'll jump into. So the data in this file has already been loaded. I just opened one of those example files. We are working here with monthly electricity consumption data, though RETscreen also supports many other types of data, including fuel consumption like natural gas, fuel oil. It has district energy, water consumption, transportation, fuel consumption usage. It also can have production data for power plants, and even you can do your own custom database. RETscreen allows for data to be entered manually or imported from Excel or CSV files, or connected databases like OLEDB or SQL servers and others. It also integrates with external platforms such as Blackstone Energy, Energy Cap, Energy Plus, Meter Connects, and others. RETscreen also allows data for larger organizations to automate data collection across portfolios with connections to systems like BGIS, Elixir, Energy Cap, NG Impact, Helios, Matrix, Urjanet, and others. And new integrations continue to be added over time. So we already have the data here. So in RETscreen, it usually has the steps on what to do. So first is the consumption data. The second step is the factors of influence. In this case, the energy consumption is primarily influenced by the weather. So degree days have been included as independent variables. The weather data is pulled automatically based on the project's location specified in the location tab. RETscreen uses either satellite data or ground station data, depending on the user selection. For this example, heating degree days and cooling degree days have been generated using a defined reference temperature, and those values are now included in the analysis table. You can add degree days here and put your reference temperature. There's a way, like if in the analytics, I'll go through it. If you don't know the reference temperature for the heating and cooling for the facility, you can start with something and then you can optimize the reference temperature based on the data for the regression model. So lastly, the event log is used to mark the dates of events that happen in the facility. So here the intensification of research activities was marked for the duration of the month of August in 2020. And we'll see this in analytics. So moving into the analytics tab, RETscreen provides several tools for data visualization and analysis. You can find things like annual bar graphs, time series, moving graph, heat map, duration curve, and more. But for M&B purposes, we'll focus on the regression analysis and QSUM chart. In this example, a linear regression model has been created to represent the baseline period, which ends just before the retrofit in January 2020. So you can see here that the dependent variable is the electricity and the independent variables are cooling degree days and heating degree days. I mentioned I was going to show you how to optimize this. You can go here, optimize reference temperature. And for example, for cooling degree days, you give a range of temperatures that the facility could have been used for the reference temperature, click calculate, and then this will show you data points for the best correlation. So usually the best correlation is the proper reference temperature to use, and which is the one used here. So RETscreen displays key statistical indicators on the model, including R² of 0.93, which is a strong correlation. And you can also see here the CV of 1.69%, reflecting a good precision model. A cool thing about RETscreen is that if you're unsure about something, you can always click on the labels and a question mark appears, and then you'll get some nice resources on how to interpret things. So next, based on this regression, a QSUM was developed, which shows basically the cumulative sum of the differences between the actual electricity and the baseline predicted electricity using the regression. And it's shown here. So downward slopes in the QSUM typically indicate energy savings or that something has been turned off or something has changed, while upward movements may reflect an increased usage or an anomaly. In this chart, we see that energy savings begin in January 2020, consistent with the start of the retrofit period. However, there's a noticeable spike in August, aligning with the laboratory event we noted earlier. Note that these are presented here in the graph. So this tells us we need to perform non-routine adjustment to fairly isolate the savings unrelated to that event. So to apply the adjustment, the original analysis has been duplicated and labeled as adjusted. Now in the options tab, in non-routine adjustments, the adjust base load has been chosen. One of several available methods in RETscreen. There's other methods, including coefficient adjustments, but we won't explore those today. So in this case, the base load was increased to 800 kWh per day to reflect the additional electricity used during the lab's intensified activity. So you can see, once applied, the QSUM flattens during the event period, showing that the anomaly has been accounted for, while the saving trend resumes in subsequent months. Below the data table, a new column has been added labeled baseline predicted adjusted, which reflects the correlated baseline used for savings calculations. And we can see that here in the month of August, that adjusted base load has been applied. And to conclude this, the M&B analysis, an M&B chart has been added, which allows you to visualize the actual electricity consumption versus the baseline predicted. So you can select here the reporting period that you want to calculate the savings for. In this case, it used the whole entire data, and it finalized the total to 18,000 kWh. But you can, like for incentive programs, there's a lot of times that the M&B has to be reported yearly. So you can basically start and end date and say, call this analysis year 1, year 2, year 3, and depending on what you need it for. Also, you can bring all these tables made and the data made that you can bring it here and report it with customized dashboards to present to stakeholders involved. You can add explanation notes and customize it, and then also you can export all these data tables using options and then export all data, and it will bring a Excel file with the data there. So that wraps up the demo for today.
You have questions, so we're good. That was good, Maria and Javier. I was really impressed. Some of the M&V stuff you have is really novel. I don't know if anyone else is doing that. We're certainly not doing that. I don't know if you know, we make software too, Option C, M&V software, but you've got some neat features that we don't have, which I liked. Okay, so let's see. Here's some questions. Here's a question about the M&V. Most of these questions are M&V questions. Does RETscreen work with linear regressions only, or is it possible to analyze nonlinear models?
Yes, there's many.
That's a great question.
Many things that you can do. I can show you here. There's multiple combinations. There's equation y equal a. There's monthly merged regressions, and yeah, there's many things that you can do.
But can it do things like, you know, in Excel, if you have a bunch of data and you just want to fit, you can do a polynomial fit. This doesn't do polynomial fits, right? It would be like cooling degree days squared times this number plus cooling degree days times a different number plus number of days or something like that.
I'm not 100%, but I can explore that more and give you an answer so you can share with the rest.
Yeah. I have a feeling. I mean, look, I don't know the software, but my guess is it's going to be a no. For the polynomial fit. How did you come up with here's a different question. How did you come up with the 800 value for the adjustment? When you were doing that lab adjustment, you know?
So basically here, I think it's here. No, here. So here it kind of is from the predicted 66 till here it's 88, so it was kind of like 24,000. It was made by the example, so that 24,000 was kind of divided daily for the month, and then that's how it was added there.
Yeah, so that's I think a method. This method is Evo put out a non-routine adjustment manual, and I think this type of method is in there. Does that sound right to you, Maria? I'm pretty sure
yes.
that's the case.
There's a non-routine adjustments methodology that Evo developed a few years back. And then there's a webinar in RETscreen's e-learning channel that goes through all the methods.
Oh, that's cool. I didn't know about that. Okay, that's cool. I did not know that. I'd like to, is there any way you can give us a link to that? I don't know how you could make that available. I mean, like, could you like put it on I don't know, somehow make it so we can see it on the screen, because I want to see that.
On the chat,
or maybe you can just go to the RETscreen, their website, and just drill down to that video, because that sounds like a really good video.
So here. So RETscreen e-learning, and then there's in the bottom there's RETscreen user communities, and there's a video that was made in collaboration with Evo. 1 second. This one, but I'm not sure. Yeah, this is not the non-routine adjustment one. Oh, here. But, the non-routine adjustments is here.
Oh wow, it's an hour and a half. Okay, good. That's great. Thank you. That's really good. That was really useful. Okay, here's a question for Javier. So when it's calculating energy savings, RETscreen, does it rely on a DOE or eQuest engine, or like basically a DOE2 engine, or does it have its own code that's going to be used to predict savings?
No, it's its own engine. Okay. So yeah, RETscreen uses its own engine for those calculations, right? So yeah.
Okay, here's you might have said this early and I might have spaced it, but so RETscreen is owned by Canada, the country of Canada, yes. Right?
Yes, from Natural Resources Canada, yes.
Natural Resources Canada, but there used to be a free version. That free version doesn't exist anymore, or do you know?
Yeah, it exists. So you just basically, when you go in fact, Marilena, you can show the RETscreen website right there. As soon as you look, you just put on your search engine RETscreen, and the very first result is the website from Natural Resources Canada, where you can download RETscreen Expert right away, and it's free to use. So of course the free version is very limited on some of the aspects. You can read all kind of files right? From RETscreen, you can
you can read other
that,
people's
but you
files,
cannot modify some stuff on those files, and I think that you cannot save some changes. So, but yeah, the free version is there. You can use it as a visualizer, and definitely you can play with it with the virtual energy analyzer, and you can see several examples right there for free. You can build some very simple models for free and go from there and take a decision. The good thing is that the model for the professional version is very is not too expensive, and it gives you 10 licenses so for a year, so you can distribute that to your team.
Oh, it's an
and
annual
make
fee.
Yeah, and pay just one annual fee. But again, that's for Natural Resources Canada. We are not related to them.
Okay. Yeah, I thought for some reason you guys were the representatives of RETscreen initially.
No. We are just users.
Just consultants.
The thing is that we use that thing every day. So,
got it.
Yeah.
I have a question for Maria. So I remember maybe 5 years ago, I saw a demo of RETscreen for M&V, and it's always impressing me because they're doing neat things. But one thing what someone told me was a drawback is, let's say you had a school district and you have, let's say, 200 meters. Can you put all 200 meters in one file? Does it have like a tree structure so that it can all go in one file? Because I thought before it couldn't, and you needed a separate RETscreen project for each different meter.
They actually develop new metering capabilities now that you can have like meter trees and all that.
Okay.
Yeah, and you can do that at the portfolio level with like automation, data upload, and all that. I haven't played around with the meter feature yet much, but yeah, I know it was just developed last year.
Okay, that's good.
It's very detailed the way now that it manages the different meters, and yeah, you can have whatever amount of. In fact, the example that you can see is that Meta Campus example. Yes, it's embedded on the tool, and even on the free version you can see it. So yeah, it's very interesting.
Okay, here's that question for Javier. So let's say you had some equipment performance curves, like chiller curves. Can you adjust those in the model?
Depending of if you can determine the COP of your refrigeration equipment, you can put an input there. And now, in fact, currently RETscreen has a new way to calculate the COP and the efficiency of heat pumps and refrigeration systems that use weather data and normalized data. So that's new. Now, for a very specific chiller curve, no, you cannot import that on RETscreen directly. So you will need to separately try to determine what will be the most approximated COP of your chiller, right?
Okay.
But that's in fact a very interesting feature to have. I will take a note of that and definitely send a message to the guys and say, hey, this is cool. It could be really cool to have that.
Okay. We had, Maria, someone, Asif said that polynomial regression is available on RETscreen. Can you do this? Can you go to the regressions tab from the left sidebar? And there's a button, select equation, just above. Hold on, this is a really bad interface. I'm struggling with. Hold on. There's a button, select equation, just above the default linear equation. You should find a couple of more options available. I guess that's it. That's linear. Oh, adjust with a secondary regression, but I don't know what that means. Oh boy. Well, okay. So according to Asif,
I got it here.
Sorry. We found it.
So you can select equation here and select. Yeah, you can have many.
Look at
I
that.
didn't know where that was. I couldn't find it. Yeah, good.
Crazy. And so wait a
Very
second.
powerful
So-
tool, I told you.
For this set of data, it's doing all of these regressions at once, and you can go through and say, I like this one the best. Is that what's happening here? So
Yeah.
it's actually doing them all automatically at the same time. Wow, that's really cool. Okay, that's neat. Hey, thank you, Asi. Another question: how do you set and control other equipment limitations in the model? So I don't know, like minimal chill water flow through a chiller. So this is a Javier.
That's very detailed to chillers. Though there is one thing. RETscreen has Marilena, in fact, can you go to file for a second to file home, and there is a power, heating and cooling right there. On that module, we don't need to click on that, but on that module you can simulate cooling equipment with in a very detailed way. So really encourage you to try the free version, go there and see those aspects on chilled water, right? You can go again in that module, you can simulate power, heating and cooling individually or as a group. So you can do a PHC project, or just a cooling project, or just a heating project, or just a power generation project, right? So you can do that. So go there. Definitely, you will find some useful tools there.
Okay, here's a question for Maria. As a frequent user, what are the top 3 pitfalls or problems or things that are missing in the current version that you would like to see added in later versions?
That's a tough one. Well, for sure, like MNB, like for MNB, like if you are following IPMVP guidelines, there's a part that you have to address when doing an MNB plan, which is like uncertainty. I think if that could be included, like it includes a lot of key values of the statistics, but if the uncertainty can also be addressed here, it would be awesome. I think that's one of the best ones. That's that's all I got.
That's it for you. That's
For
okay.
now.
That's okay. How about you, Javier? What do you got? The top 3, if you have 3.
More than top 3, in fact, maybe it's just there is one aspect on the financial modeling that could, and it's very simple. It's just to not simulate better, but to make it easier to build the case for grants and loans separately, right? So I mean, you can, if you have for example, you have four projects, right? But you need on the same building, and you want to combine them, see the different scopes. But you have to apply for, of those 4 projects, to only, you have the opportunity to apply for only 2 different financial programs. That complicates the way that the financial model needs to be done. Again, doesn't mean that RETscreen cannot do it. It can, and it will do it, but it's not straightforward, right, on that end. But if everything is inside one single program, fine, that's absolutely no issue, right? The other thing, maybe I mean, try to you already have the possibility to put on a building slash facility energy model the power generation options, right? But one thing that definitely can be added, and I'm pretty sure it will be done in the next revision, is the use of diesel gensets on facilities.
Mm.
So I mean, and not well, it could be as a project. Why not? You have to compare things.
Uh-oh,
We lost you.
we lost him. Okay, I'm going to move to the next question. Let's see, this is, okay, I got a question, but I'm not really sure. He said, can you see the curve used in the model? Is he talking to, Maria, when you do M&V, can you see the curve? Or maybe you can see the linear regression, right? Or the,
Yes.
okay,
I
so
can show you one.
it must be, Javier, we can't hear you anymore. I think that your audio, your Bluetooth is dead or something.
You can see it here, one
Okay,
example.
so that might be his question, but his question might also be, now I don't know, Maria, if you know much. Okay, so I don't know, Maria, if you know much about the modeling half. Do you know anything about that? It's okay, Javier.
For the
I'll
energy part,
understand.
yeah, sure. Shoot.
Okay, so
Okay. No, you're back.
oh, he
Okay,
came
yeah.
back.
Oh, shit. I don't tell me that you lose everything that I say.
Yeah, we did, but we're
Yes.
moving on. We only have a few minutes left.
Oh,
So
man.
so let's move on to the chiller curves that are in the model. Is there a way to see the chiller curves that are used in the model?
You need to see, no, not on this facility model. It needs to be a very specific power heating and cooling generation model where you may be able to see that. I'm not very familiar with, to be honest, I'm not very familiar with that specific model. We
Okay.
don't use that too frequently.
Here's another question. Is Canada pushing for decarbonization? Also, does RETscreen have air to water heat pump models for heat pumps to replace gas boilers?
Air to water. Yeah, you can in the energy model you can select a heat pump, and from there you can select what's the fuel. So, and if you see at the very this is your heating system. So you select that, and you can create a domestic hot water system on your building, and then on the domestic hot water system, use RETscreen will tell you what heating source is the one that you are using. You select heat pump, and now your domestic hot water system is using a heat pump. That's air to water, right?
Okay.
And you can even use ground source heat pumps.
So another question, can it handle, and Maria, maybe you should answer for Javier, can it handle time of use electric rates? Actually, I'd like to know for M&V, you can convert it to dollars, right? To Canadian dollars or American dollars, your M&V results? Okay,
Yeah.
so then can you model rates in the M&V part? It has a rate modeling engine? It does. Okay, and then the next question is, can it handle time of use? Javier, you're shaking your head. So you're saying, yes, it does. For the energy, it does.
There is a rate calculator right there on the little connector there.
Okay.
And you can do basically whatever you want. Yeah, it's very detailed.
Okay. Okay, so that's it. I think we made it through all the questions. I really appreciate your help. So if you want to talk to Javier or Maria, that's how you can. If you want to email them and ask them questions, go do that. Hey, you guys, thank you so much. That was great. Thank you. Thanks
Thank
everyone
you for the
showing up.
opportunity.
Thank you.
Yeah.
Thank you.
Thank you. Take care.